When we are solving quadratics, you remember that what you're trying to do is find the value of x when y is equal to 0. We're taking into account the fact that our standard form quadratic function is written as y equals ax squared plus bx plus c, where in reality what we do is we substitute 0 in for y. And then what we have done in last section is then you factor. Almost always you get 2 parentheses and then you set each parentheses equal to 0 and you solve. What we're doing now is we're going to talk about the idea that what happens when it's a special case quadratic, or it's a quadratic that you can actually find the value by unsquaring, which we call finding the square root. Remember, the square root is kind of like an unspoken 2 there, and this is saying what number to the power of 2 gave you the inside. So with that in mind, let's review quickly what square roots represent. A square root is used to solve quadratic equations because it unsquares something. Remember when we had equations such as 4x is equal to 12? The way to solve is to undo what's being done to x, and x is being multiplied, so you divide. Where multiplication and division are inverse operations. Same thing if I had something like x minus 5 equals 10, I added to undo. Because addition and subtraction are inverse operations. With that, the same exact type of thing can be applied when you are trying to unsquare something. So if I had an equation where I had x squared is equal to 16, in order to unsquare, so the inverse of squaring is taking the square root. And that's where we get x is equal to 4. Now we're in that advanced stage of math where we have to also remember that every square root actually has 2 possible answers. Remember that squaring something is something times itself. Besides 4 to the power of 2, what other number to the power of 2 will also give you positive 16? Negative 4 times negative 4 is positive 16. So, in reality, when you take the square root of a number, you don't just get 4, in this case, you get positive and negative 4. There are 2 roots. There are 2 solutions.
I learned this last year.
So, for example, 3 times 3 is the same thing as 3 squared, and 3 squared is 9, and the square root of 9 is 3. Negative 3 times negative 3 is negative 3, in parentheses, the whole thing to the power of 2, and the square root of that can be negative 3. So, when you take the square root of a positive number, remember that, and specifically if the sign of the square root is not indicated, you must find both the positive and negative square roots. So for example, if I asked you to solve a quadratic that looked like this, x squared plus 15, x squared equals 15, then what you're going to do to unsquare is to take the square root, but your answer is going to be positive and negative square root of 15. The reason that you would leave it as the square root of 15 is because it's not a perfect square. Very good. Just make sure you remember that when you take the square root of something, your answer is positive and negative of whatever the value is. So here I have a quadratic. I know it's a quadratic because it has the exponent of 2. If I'm asked to solve, I don't have to worry about setting it equal to 0 because the only thing I have to do to get x by itself is to unsquare, which means I take the square root. And when you take the square root, you get that x must be positive and negative 13. This means in terms of the parabola that your u would cross at positive 13 and negative 13. So that's like a really wide u, isn't it? That's what it would mean. Because a is positive, it would open up. Right?
That's easier.
Yes. So let's try this. In this case, please remember, you cannot take the square root of a negative. When you go to take the square root to unsquare, if you were to punch that into the calculator, you would get an error message. Square root of negative 49. You can't do it. It's called an imaginary number, which you will learn about in Algebra 2. You can't take the square root of a negative. This means no solution. And in terms of the graph of the parabola, remember, the value of x when y is 0 is looking for x-intercepts. That means there are no x-intercepts. That means that the parabola is either going to open up away from the x-intercept or down and never cross the x-axis. And in this case, because a is positive, it opens up and it never crosses the x-axis. So in this case, it is no solution. So when you have an equation and you're trying to solve it and it is a quadratic, first you have to try to get it by itself. When you subtract that 7, you're going to get x squared is equal to 0. And to unsquare, I take the square root and I get that x is equal to 0. Because of the fact there is no positive and negative 0, your answer is just 0. It means you're crossing, again, just to implant it in your head, you're crossing at 0. That's your x-intercept is just 0, which means that's the only point that you cross. So that's what it would look like.
And then if you check.
Okay, next guy. Now, at this point, we're hoping that you recognize special cases just by looking at them. And if you look at letter B, you notice that 16x squared minus 49 is a special case. It is what we call the difference of perfect squares, that it's going to be x minus a number and x plus a number. In this case, the square root of 16x squared is 4x, the square root of 49 is 7, and because there's no bx, I know that they are conjugates. They are opposite inverse operations. So that's one way to do it. Then from here, I have to set each parentheses equal to 0. And I subtract 7 on this case. And I get 4x is equal to negative 7, that when I divide by 4, it's x equals negative 7/4, and you can leave it as an improper fraction. And this one you're going to add 7, and you get 4x equals 7, of which you divide by 4 again, and you get x is equal to 7/4. So your two answers are negative 7/4 and 7/4. And you can abbreviate it like positive and negative 7/4 because it happened to be the same value. I do want to show you another method of doing this question. So those of you guys that do struggle a little bit with perfect squares or difference of perfect squares, I want to show you another method that might be helpful. We know that this equation, as it's written, if I wrote it originally, 16x squared minus 49 is equal to 0, is the object is to solve for x. If I added 49 to both sides and I got 16x squared is equal to 49, and then I divided by 16 so that I could get x squared by itself, I would get x squared is equal to 49 over 16. From that, if I take the square root, I am going to get that x is equal to positive and negative. Well, the square root of 49 is 7, and the square root of 16 is 4. I still get the answer of positive and negative 7/4 if I did it this way, as opposed to the way that I just did over here. You get the same answer. So if it's a binomial, such as it is here, where it's two terms, if you add and then divide, you could potentially get the square root in the same way that we got for these questions here. All right, so that's the other method. Now, let's look at letter C. Letter C, and there's is talking about this entire parentheses being squared and it equals 16. So the first thing I want to undo is that squareness. And to undo that, to undo the squaredness, I take the square root. Whatever you do to one side, you do to the other. When you took the square root, you eliminated the square. So now you have x minus 5 is equal to, please remember that the square root of a number is positive and negative, in this case 4. I am not done yet because x is not alone. What still needs to be done to x?
Add 5.
You must add 5. This is going to leave you with x is equal to two different problems. Positive 4 plus 5, positive 4 plus 5, and negative 4 plus 5.
Could you also do 5 minus 4?
Or 5 minus 4. So your first answer is 4 plus 5, which is 9. And the second one is negative 4 plus 5, which is the same thing as 5 minus 4. And that gives you 1. So your value of x is 9 and 1. Notice that you don't get plus and minus 9 because the order of operations said that what you do first is unsquare. You get a positive and a negative of 4. And then when you add 5, you're adding 5 to positive 4 to get the first answer, and you're adding 5 to negative 4 to get the second answer.
What is the test?
Of course, we're going to have some word problems to see the real world application of this stuff in the real world. When solving quadratic equation by using square roots, you may need to find the square root of a number that is not a perfect square. In this case, you get what's called an irrational number, and when you punch it into your calculator, you have to make sure that you press another button that makes it into a decimal. For example, if I am trying to find what x is equal to, and I'm unsquaring, I would get x is equal to the square root of 15. Let me show you on your scientific looking calculator what this would look like. You would have to figure out the square root of 15, and by doing that, you're going to do the square root symbol, which is above the x squared, and then you're going to do 15, not 16, 15, and you press enter, and it's going to give you the decimal itself. Blah, 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 blah. So the number that we got was 3.8729. They want us to round to the nearest hundredth, so 3.8729 rounds to 3.87. And remember that when you take the square root, you get positive and negative, so it's plus and minus 3.87 is the solution to this. Cool. Next guy. All right. We are trying to find the answer, and so we're isolating x. In order to get x by itself, what would be the first thing that you would want to do? Subtract 90 to both sides. Remember, you're undoing what's being done in inverse order. You get negative 3x squared is equal to negative 90.
You can't do that.
You can't assume that you can't do it because what's the next step?
Oh, add 90.
Divide by negative 3. And when you divide negative 90 by negative 3, you get positive 30. Of which, when you take the square root of 30, it's positive and negative 5.477, which rounds to 5.48. Excellent. Miss Pirzada is building a retaining wall along one of the long sides of a rectangular garden. So in my head, I always picture pictures. Rectangle. One of the long sides. Okay, so it's this guy here. The garden is twice as long as it is wide. So if I call this W, the length is 2W. It also has an area of 578 square feet. That means that the length times the width, because that's what area is equal to 578. What is the length of the retaining wall? That's this guy. Well, I know that the area is length, 2W, times width, times W. And all of that is equal to 578. This means 2W times W is 2W squared is equal to 578. Solve for W, divide by 2 on both sides, and I get that W squared is equal to 289. In order for me to solve for W, I have to take the square root. Normally, I would say positive and negative 17, but because it's width and it's a real world problem, we're going to ignore the negative. So that means that the width is 17. But they asked me for the length of the retaining wall, and the retaining wall is 2W. So the retaining wall is 2 times 17,
38.
which is 34 feet long. That's the length of the retaining wall. We're going to be doing the independent practice. For today, 8.6, you're going to only work on evens because we're going to go ahead and do 8.7 right now.